Hi everyone, this is the 94th video of the ACT Math Practice Problem series, and here we have a nice problem from the concept of rhombus in geometry. As I always recommend, before seeing the solution, you can pause the video and give it a try yourself, and after that of course you want to match with my solution. So let's get started. Here the question says, all sides of a rhombus are the same length as shown below. Here we have a rhombus ABCD and the side lengths are all equal. Let's assume those are all like A inches, right? So I have used a variable A to indicate the length of each of the sides. If one diagonal is 16 inches long and the other is 24 inches long, how many inches long to the nearest hundredth of an inch is a side of the rhombus? So essentially we have to calculate the length of each side of this rhombus, and of course all sides are of equal length, so we just have to calculate the side length of this rhombus. Now one important property of rhombus is that the diagonals bisect each other at right angle. So two things here, right? The diagonals bisect each other at right angle. That means if the intersection is at O, for example, I'm just using a name there for this intersection. Let's say this is the point O, and that is where both diagonals of this rhombus would bisect each other. And also because they bisect at right angle, so this would be a 90-degree angle. Now if I simply focus on this triangle which is AOD, so now let's think about the AOD triangle. There you see that AO would be how much? AO would be half of AC, and AC is the smaller diagonal which is 16 inches long, and BD is the larger diagonal which is 24 inches long. So half of AC would be 8 inches then, so that means AO would be 8 inches. And similarly, how about OD? Well, OD would be equal to half of BD. Since the diagonals bisect each other, so each segment of the diagonal would be equal. That means BO would be equal to OD. So OD would be half of BD. And what is the size of BD? Well, BD is actually 24 inches. So you can say this is half of 24, that would be 12 inches, right? So now in the triangle AOD, you can clearly see that it is a right triangle because the angle AOD is a right angle, and we know the two sides of that triangle which are AO and OD. So AO is 8 inches and OD is 12 inches, right? And if it is a right triangle, then it's very easy. Then AD, which is the hypotenuse of this right triangle, that is actually one side of the rhombus. That's exactly what we have to calculate. So from here, all we have to do is we have to calculate the size of the hypotenuse of this right triangle, and hypotenuse AD would be like this. Well, from Pythagoras theorem, we know that AD square would be equal to AO square plus OD square, which is equal to 8 squared plus 12 squared. And that is equal to 64 plus 144, which is equal to 208. So from here we can say that AD must be equal to square root of 208, and that will be equal to 14.42. If you punch in this number in calculator and do a square root of 208, it will turn out to be 14.42. So that would be in the unit of inches. So we have found out that the length of one side of the rhombus is 14.42 inches. That means the length of each side of this rhombus would be 14.42 inches. And that is our answer. So if you look at our answer options, we have 14.42 under option F. So option F is the correct option. I hope everything made sense. Thank you for watching. See you in the next video.